Hi everyone, in this video we will cover past paper questions related to chapter 12 Preparation of Salts. Okay, before starting the question we have to memorize some of the basic concepts related to this chapter, and the basic concept in this chapter is about the salts, that which salts are soluble and which of them are insoluble. Remember that all nitrates are soluble in nature, all sodium, potassium, ammonium salts are also soluble. Most chlorides are soluble except for the lead chloride and the silver chloride. Okay, most sulfates are also soluble except for barium sulfate, lead sulfate, and calcium sulfate. The carbonate salts are insoluble. Same is for hydroxide salts. They are also insoluble. Exceptional cases are these: sodium, potassium, and ammonium. Okay. So now we already know the solubility. So we have to choose the best method for the preparation of the salts. There are two main methods. One is the method in which the reactants are, one of the reactant is insoluble and the other one in which both the reactants are soluble. Okay. So the first method in which the one reactant is insoluble, we have to use add excess solid method, in which the reactant that is actually insoluble, we have to add it in more amount. Okay. Now, the second method in which both the reactants are soluble is further divided into two types. One is titration and the other one is precipitation. In titration method, if your product is also soluble, then we will use this method, okay? But if your product is insoluble, but both the reactants are soluble, then we will use the precipitation method for the separation of the reactant and the product. Okay, now let's see one by one each question. Okay, let's see first question. Which reaction is an example of photochemical reaction? A. Glucose forming carbon dioxide and water. This is a respiration reaction and we don't need any light for this reaction, okay? Photochemical means the reaction that needs light energy. Magnesium reacting with oxygen, no need of any conditions. Potassium reaction with water, no need of any condition. Silver chloride forming silver metal. Yes, this reaction needs light energy as a catalyst. The bond between silver and chlorine is broken in the presence of light energy. Okay, so that's why option D is the right option here. Let's see question 3. Which type of reaction is represented by the equation shown over here? So these are the option: addition, redox, neutralization, precipitation. If you see it carefully, PB is aqueous here, but in this product, it is giving you a solid, right? So it means the aqueous is converted into a solid. So this is a precipitation reaction. Why not neutralization? Why not redox? Why not addition? Because no acid-base reaction is involved. No addition, reduction is involved over here, or oxidation is involved. So option D is the right option here. Question 4. When dilute sulfuric acid is added to solid X, a colorless solution is formed and a gas is produced. What is X? Okay. So whenever acids react with a solid, and that solid is actually a metal oxide or carbonate, remember that with metal oxide, it will always produce a salt and water. But with carbonates, okay, it will always produce a salt and also carbon dioxide gas. So that's why they are talking about a gas here. So the answer should be copper carbonate or sodium carbonate. Remember that copper is actually, it will not react with sulfuric acid. You have to remember that copper is actually very less reactive. Okay, so copper will not react with sulfuric acid. So we are just left with the option sodium carbonate. So when sodium carbonate reacts with sulfuric acid, a gas, carbon dioxide, will be formed. Compound P reacts with hydrochloric acid to produce a gas that turns lime water milky. So this one we already know everywhere, that if the lime water turns milky, carbon dioxide gas is actually has been produced. So it means the compound which is P, it should be a carbonate. So we are only having one option here, that is sodium carbonate, right? So option A is the right option here. Which will describe and gives the formula of hydrated copper sulfate. Okay, hydrated copper sulfate means it has water molecules that are trapped inside the salt, right? So water molecules, if they are trapped inside the copper sulfate, it means it is chemically combined there, okay? It's not an aqueous copper sulfate. We cannot call it hydrated one. So that's why 5 water molecules per 1 mole of copper sulfate are trapped inside it. So that's why option D is the right option here. Copper sulfate chemically combined with water molecules. And the formula is CuSO4.5H2O. Already given in chapter 9, you can see over there. Question 7. An excess of aqueous sodium sulfate was added to aqueous barium chloride and the mixture was filtered. Which row shows the identity of the residues and the substance present in the filtrate? Okay, so now we have to see which method was actually used here, right? So if you see aqueous sodium sulfate and aqueous barium chloride, both are actually in aqueous form. They are in the soluble form. So it means they are using which method? And then they are using a filtration method. It means this is a precipitation method. Okay. So it means our product was not soluble. So which product we can get over here? Sodium chloride and barium sulfate. Sodium chloride, we already know that this salt is soluble. So we are left with which option? Barium sulfate. So it means the residue will be barium sulfate, right? A and B. And I already have told you that you have to memorize that which salts are insoluble. Most of the sulfate salts are soluble except for the barium sulfate and lead sulfate and calcium sulfate, right? So barium sulfate is insoluble. That's why A and B option can be right. Now, substance in the filtrate. Okay, the filtrate will have the dissolved solution, right? So which one can be there? In that one, we will have sodium chloride, of course, because it is our product. But which one will be the reactant? Which reactant is in excess? You can see over here, it is sodium sulfate is in excess, right? So that's why sodium sulfate will be the option here. Sodium sulfate and sodium chloride. Okay, so option D is the right option here. Why we can't choose barium chloride? Because barium chloride is not in excess. We have used all the barium chloride. Aqueous sodium sulfate is in excess amount, so it will be left over. So that's why sodium chloride and sodium sulfate will be in filtrate. So option B is the right option here. Okay, let's see question A. The apparatus shown is used to prepare aqueous copper sulfate. What are X and Y? If you see, the solid X is a reactant here. And then in the product, if you see here, the product is soluble, right? But we are using the excess of solid method, right? So it means our reactant X is insoluble. So we have to find the reactant that is insoluble. If you see the copper, okay, copper cannot be the answer over here because we are producing the copper sulfate here, right? And with the sulfuric acid, and with sulfuric acid, copper don't react. Remember that the copper don't react with the acids. Now we are just left with three options. Sulfur cannot be the option over here because we don't have sulfur here, right? Because we already have sulfuric acid in the reactant, one of the reactant, right? So it means this should not be the sulfur one. Now we are left with B and C, copper chloride or copper oxide. Chloride, all chlorides are soluble, right? Except for the silver chloride and the lead chloride. So it means copper chloride is soluble. We cannot choose also this option. This solid X is actually insoluble. So now we are just left with copper oxide. So it means copper oxide is insoluble. So that's why we will use excess solid X method, okay? So copper oxide, it is actually solid in nature, and then sulfuric acid. So we will get the option C over here. So option C is the right. Question 9. Which reaction mixture will produce a precipitate? So now let's see one by one each of these methods. Okay, aqueous sodium carbonate when react with aqueous copper sulfate. So what will be the product now? They have to exchange with each other. Sodium sulfate. All the sodium salts are soluble, so this one is soluble. Copper carbonate. Yes. The carbonates are actually insoluble except for sodium, potassium and ammonium. It means this product will give you what? It will give you a copper carbonate which will be precipitate, right? So that's why option A is the right option. We don't have to look for other options. Question 10. The solubility of some salts is shown over here, okay? Which two aqueous solution produce an insoluble salt when mixed together? Okay, you can see all of these one by one. So first of all, barium chloride and zinc nitrate when react. So barium when react with zinc nitrate, barium chloride. So barium will go into nitrate, right? So barium nitrate and zinc chloride. So see barium nitrate, all nitrates are soluble. So this is soluble. Zinc chloride, again, most of the chlorides are soluble. So this one will not produce an insoluble salt, right? Now let's see next one. Barium nitrate and lead nitrate. Of course, they are nitrates, so all nitrates are soluble. Even if they get exchanged, it will be still a soluble salt. Now let's see for C and D option, lead nitrate and potassium carbonate. So mostly the carbonates are insoluble, right? So if we are getting the lead carbonate and potassium nitrate, so potassium nitrate is soluble, but lead carbonate, of course, will be insoluble. So from option C, we are going to get what? We are going to get an insoluble salt. So that's why option C is the right option here. Question 11. Which two compounds would react together to form the insoluble salt lead chloride? Okay. So to make the lead chloride, we will see one by one each option. Lead nitrate. Okay, lead nitrate has a solubility in the water, right? So we have to choose a method in which we get a product that is insoluble, right? But how we can get a product insoluble? If both the reactants are soluble. So both the reactants should be soluble. Then lead nitrate and sodium chloride will be the best option to be react together, and then we can get a lead chloride over here, right? So 1 and 4, that is option B, is the right option here. Okay, question 12. An aqueous solution react with a solid. The products are an alkaline gas, a salt, and a water. What are the aqueous solution and the solid? Remember that alkaline gas, the example in your book is given for the ammonia. Okay, so ammonia is an alkaline gas. So you have to find the solid and aqueous solution that has ammonium in it. We have to find. So you can see over here in which options we can find ammonium here. Ammonium chloride, right? So C or D option can be right. So ammonium chloride will be the solid. And now let's see the aqueous solution. Remember that ammonium chloride or ammonium salts, whenever they react with a base, then they will give you ammonia, not with acid, okay? So when they react with a base, so which one is a base here? Sodium hydroxide. So whenever base reacts with ammonium salt, we will always get a ammonia gas that is alkaline in nature, okay? So that's why option D is the right option here. Let's see next question. All metal nitrates are soluble in water. All metal chlorides are soluble except silver and lead. All metal carbonates are insoluble except sodium and potassium. Which aqueous solution produce a precipitate when mixed together? Okay, now let's see one by one. Silver nitrate will give you what? Silver nitrate will give you silver carbonate and sodium nitrate. Sodium nitrate, of course, will be soluble, but silver carbonate will be insoluble because all carbonates are insoluble. So this one will give you one precipitate. Now let's see this one. Silver chloride. All chlorides are soluble, right? Except for the silver and lead. Remember that? So that's why this option will also give you what? It will also give you a precipitate. Now let's see the third option. Barium nitrate and potassium chloride. So barium chloride. Okay, all chlorides are what? All chlorides are soluble, right? Except for what? Lead and silver. So barium chloride is soluble, right? We will get a soluble one. Potassium nitrate, of course, all potassium salts are soluble and also nitrate salts are soluble. So third one will not give you a precipitate. Only 1 and 2 give you a precipitate. So that's why option A is the right option here. Question 14. A student mixes silver nitrate and barium chloride to form a white precipitate of silver chloride. The equation is shown over here, okay, which will describe the solubility of the salts. So which one of them are soluble? We have to check one by one. AgNO3 silver nitrate. All nitrates are soluble, yes. Okay, so this one is also soluble. This one is also soluble, right? Now we are just left with this. So silver nitrate is not only the option. This is rejected. Silver and barium chloride, yes, this can be right. But we have to see first here, are these soluble or not? Barium chloride. Remember, all the chlorides are soluble except for silver and lead. So it means barium chloride is also soluble, right? And barium nitrate is also soluble. So AgNO3, BaClO2, and BNO3 into 2. Silver nitrate, barium chloride, yes, and barium nitrate. All of them are soluble. C and D can be right. Now we have to just look for the silver chloride. So silver chloride, remember there are only 2 chlorides that are insoluble, silver chloride and the other one is lead chloride. So this is insoluble. So insoluble is silver chloride, right? So this C option is the right option over here. Clear? So that's why this option is right. Sorry, I thought that this is barium nitrate, but this is not barium nitrate, this is silver chloride, okay? So that's wrong. So C is the only right option here. Let's see question 15. Copper sulfate is a soluble salt. Calcium sulfate is an insoluble salt. Which row shows suitable reactant for preparing a pure sample of the named salt? First option, calcium sulfate, okay? And the reactants are calcium carbonate and dilute sulfuric acid. These reactants can be right if our salt is also soluble. But if you see our salt is insoluble, the calcium sulfate is insoluble salt, so we have to use the reactant that both are soluble. Calcium carbonate is insoluble, right? So we cannot use this method. Let's see for option B. Calcium sulfate is produced by using the reactant aqueous calcium chloride and aqueous sodium sulfate. Yes, this option is the best option. Why? Because both the reactants are soluble and it is giving you a product that is insoluble. So we can use a precipitation method to purify the pure sample of calcium sulfate. Now for C and D, why they are not right? So we already have chosen the B option. C and D we can check. Copper and dilute sulfuric acid. No reaction will take place because copper don't react with any acid. Fourth option, copper sulfate. Because copper sulfate is a soluble salt and then both the reactants are also soluble. So this is a titration method. We cannot get a pure sample of the this salt. Okay, so that's why the B option is best as compared to the D one. So that's why we'll choose option B. So option B is correct. Let's see question 16. Which statement about calcium carbonate is correct? It is made by thermal decomposition of limestone. Wrong, because limestone itself is actually calcium carbonate. It is used to neutralize alkaline soil. Wrong, it is used to neutralize acidic soil because calcium carbonate is alkaline in nature. It is a reactant in the test for carbon dioxide. Wrong, calcium carbonate is not used as a reactant. Actually, aqueous calcium carbonate, or we can see the lime water. Okay, so the lime water is actually used for the test of carbon dioxide. Option D, it is used to remove impurities in iron extraction. Yes, that's right. In chapter 16, you can find the answer that we use calcium carbonate for the iron extraction method. So that's why option D is correct over here. Let's see question 17. Which of the following methods are suitable for preparing both zinc sulfate and copper sulfate? First, reacting the metal oxide with warm dilute aqueous sulfuric acid. Right, whenever metal oxides react with the acid, for example sulfuric acid, then we will going to get the sulfate salts and also water. Now let's see the second option, reacting the metal with dilute aqueous sulfuric acid. Yes, mostly when metal react with the acid, they produce the salts, right? But in this term, the metal copper will not react with any of the acid. Either it's sulfuric acid or it is HCl, okay? So that's why option 2 cannot be right. Third, reacting the metal carbonates with dilute aqueous sulfuric acid. Yes, this option is right because whenever metal carbonates react with the acid, they will produce the salt and also the carbon dioxide if the acid is sulfuric acid. So that's why 1 and 3 options are right. That is option B. Let's see question 18. Which methods are suitable for preparing both zinc sulfate and copper sulfate? First, reacting the metal oxide with warm dilute aqueous sulfuric acid, reacting the metal with dilute aqueous sulfuric acid, reacting the metal carbonate with dilute aqueous sulfuric acid. All these options are same like the previous question. So 1 and 3 option is the right option here. That is C. Let's see question 19. Information about the solubility of salt is shown over here. Aqueous solution of which two compounds would produce a precipitate when added together? Now let's see one by one each option. Barium nitrate, soluble. Calcium chloride, also soluble, right? Okay, except for lead and silver. So now what will be the product? The product will be barium chloride, soluble. Calcium nitrate, again soluble. So we are not going to get a precipitate. So this option is rejected. Now let's see the second option. Copper sulfate will give you copper nitrate, soluble. Zinc sulfate, also soluble. Okay, so this one option is also rejected. Now we are left with potassium chloride and sodium sulfate. So, okay. So, potassium sulfate, soluble. Sodium chloride, again soluble. So, now we are just left with option D. So, that's why option D is the right option. But we can still see why it is right. Lead sulfate. So if you see over here, lead sulfate is insoluble. And magnesium nitrate, of course, it will be soluble. So one precipitate we will get from this reaction. Okay, so that's why option D is the right option here. Okay, let's see question 20. Silver chloride is insoluble in water and it's prepared by precipitation. Which two substances can be used to make silver chloride? Okay, so this salt is insoluble. So we need both the reactant that should be soluble. Okay, so barium chloride. Barium chloride is a soluble salt. Silver nitrate is also a soluble one. So when they both react, we can get silver chloride. So this option is the right option over here. Okay, why not option B? Because silver is less reactive, so it will not react with any of the acid. Hydrochloric acid, it will not react. Hydrochloric acid and silver bromide, again, there will be no reaction. Why? Because the bromide, silver bromide is insoluble, so it will not react. We need both the reactant soluble one. Sodium chloride and silver iodide, again, all the halogen salts of the silver are insoluble, okay? So that's why silver iodide, again, it will not react with sodium chloride, okay? So that's why we are just left with option A. So option A is the right option here. Okay, let's see question 21. Which two compounds give a white precipitate when their aqueous solution are mixed? Silver nitrate and sodium chloride. Okay, so what we are going to get over here, we will get sodium nitrate and silver chloride. And remember, silver chloride is white in color. Why not silver iodide? Because it is yellow in color. So option A is the right option here. We don't have to look at the other options. Okay, let's see question 22. The following substances can be reacted together to prepare salt. First, copper oxide and excess hydrochloric acid and excess sodium hydroxide, hydrochloric acid and excess zinc carbonate. In which reactions can the excess reactant be separated from the solution by filtration? So we can only separate the excess reactant if it is solid in nature, or we can say it is insoluble. So let's see the first one, excess hydrochloric acid. Of course, it's liquid, right? It's aqueous, so we cannot separate it through filtration. Second, excess sodium hydroxide. Again, it is aqueous, so we cannot separate it. Excess zinc carbonate. Yes, it's an insoluble salt, right? So we can use this method. For this one, we can use the filtration method. So option D is the only right option here. Question 23. Lead sulfate is an insoluble salt. Which reaction produces a mixture from which lead sulfate is obtained by filtration? So of course, it's an insoluble salt. So we have to use both the reactant that are soluble. Okay. So now let's see one by one all these options. Adding solid lead carbonate to dilute sulfuric acid. Wrong, because this is insoluble. Adding solid lead hydroxide, again, this is insoluble. We cannot use this method. Adding metallic lead to dilute sulfuric acid, again wrong, because lead will not react with any of the acid. Adding aqueous lead nitrate to dilute sulfuric acid. Yes, this method is the right option. Why? Because both are soluble, so when we can use the filtration method for this one. So option D is correct. Okay, let's see question 24. Which substance react with dilute sulfuric acid to form a salt that can be removed from the resulting mixture by filtration? Okay, so now we have to use two reactants that both are soluble and our product should be insoluble. That's why we can use the filtration method. So aqueous barium chloride can be the option. Aqueous sodium hydroxide can be the option. Copper, of course, it cannot react with acid, so this is not the right option. Copper carbonate, again, not the right option because copper carbonate is insoluble reactant. So we cannot use the insoluble reactant to produce an insoluble product, okay? So A or B can be right. Now we have to see that when barium chloride with sulfuric acid, are we going to get an insoluble salt, yes or no? So let's see, when barium chloride react with sulfuric acid, we are going to get barium sulfate. Okay, and HCl. So barium sulfate is an insoluble salt. So A is the right answer because aqueous barium chloride will give you an insoluble salt. So option A is correct. Question 25. Some general rules for solubility of salt in water are listed over here. Okay. Which substance produce an insoluble salt when aqueous solution of them are mixed? Barium chloride and magnesium nitrate. Okay, so when barium chloride and magnesium nitrate solution will be mixed, what we are going to get? Barium nitrate and magnesium chloride. So both are soluble, so that's why we are not going to get insoluble salt. Now let's see for calcium chloride and ammonium nitrate. So ammonium chloride and calcium nitrate, again soluble, so we are not going to get an insoluble salt. Silver nitrate and zinc chloride. Okay, zinc nitrate, of course, soluble, but what about silver chloride? If you see over here, silver chloride is insoluble, right? So that's why option C is the right option over here. Let's see question 26. A white precipitate is produced when small amount of two colorless solutions are mixed together. Which pair of solution produced white precipitate? Let's see one by one each option. Sodium hydroxide and zinc nitrate. Okay, so when sodium hydroxide and zinc nitrate will react, what we are going to get? Zinc hydroxide and sodium nitrate. Okay, so it will produce a precipitate, right? So option 1 can be the right one. Sodium hydroxide and aluminium chloride. Again, we are going to get aluminium hydroxide and sodium chloride. Sodium chloride are also white precipitates, but they are soluble, right? Now let's see again, barium chloride and sulfuric acid. So barium chloride will produce what? Barium sulfate, and then we are going to get HCl. Again, barium chloride is a white precipitate. Acidified barium nitrate and potassium sulfate. Again, we are going to get over here barium sulfate and potassium nitrate. So all of these will produce white precipitate. That's why option A is the correct option here. Question 27. The equation for 3 reactions are shown over here. Which reactions are suitable for making a salt by precipitation method? That's obvious from here. If you can see these one. So this one is producing a product that is solid. This one is also producing a product that is also solid. So it means they both are precipitate. But this one is a soluble one, and they will use a titration method, not the precipitation method. Okay, so 1 and 2 are the right option. That is A. Question 28. Information about some silver compound is shown in the table. Which equations show a reaction which cannot be used to make a silver salt? So now let's see one by one. So AgCl, if you are producing a precipitate, both the reactants should be soluble. Yes, so both the reactants are soluble. Again, this one is a soluble one. Then we can we use one solid and the other one should be aqueous? Yes, that's also right. We can also use this method. Because the product is soluble, one of the reactant is soluble, so the other reactant is insoluble. That's all right. But one product and also one reactant should not be solid. So let's see this option. D is the wrong option here because first of all, Ag never reacts with the acid. Second, both are solid, right? So we cannot use this method. So that's why option D cannot be used to make a silver salt. Okay, let's see question 29. 4 stages in the preparation of a salt from an acid and a solid metal oxide are listed. First, add excess solid. Second, evaporate half the solution and leave to cool. Third, filter to remove the unwanted solid. And fourth is heat the acid. In which order should the stages be carried out? So we are using the excess solid method if you see over here because we are using the solid and in an excess amount. So of course, this solid is insoluble. So that's why we also have to heat the acid. So 1 and 4 will go side by side. So where we can find 1 and 4 together, this is the only option that is C. 4, first heat the acid, then add excess solid. Then filter to remove the unwanted solid and then evaporate half the solution and leave it to cool. So that's why option C is the right option here. Let's say question 30, an acid is neutralized by adding an excess of insoluble solid base. A soluble salt is formed. Okay, so they have used an add excess solid method in which one of the reactant is insoluble but the product is a soluble one. So how is pure salt obtained from the reaction mixture? So first of all, we have to remove this insoluble solid base, right? Because this was in excess amount, so the excess we have to remove it. So which method we have to use? Filtration. So first of all, we will do the filtration one. So now this reactant has been removed. Now we are just left with our product that was soluble and also this acid, okay, this reactant. So how we can separate these together? We have to do the evaporation method so that all the reactant is evaporized and we are just left with the soluble salt. And that soluble salt will form the crystals. So that's why filtration, evaporation and crystallization. This is the right answer. That is option D. Question 31. A method used to make copper sulfate crystal is shown. Okay, what are the purpose of step 3 and step 4? So what is the step 3? Add copper oxide until it is in excess. Okay, so why we have to use it in excess amount? Because we want all the sulfuric acid to be used in this method. Okay, so that's why to ensure all the acid has reacted, A or B option can be right. Now what about the fourth? Filter the mixture. Why we will filter the mixture? So that we can remove this excess copper oxide now. So to obtain the copper sulfate or to remove the excess copper oxide? Yes, this option is right, to remove the excess copper oxide. Because copper sulfate is soluble, right? So this is not the right option. This is the right option, that is B. So B is the correct option here. Question 32. Copper carbonate is formed when aqueous sodium carbonate is added to aqueous copper nitrate. The ionic equation for the reaction is shown over here. How is pure copper carbonate obtained from the reaction mixture? So copper carbonate, all the carbonates usually are insoluble, and you can see also in the reaction it is soluble. So it means it's a precipitate, right? So we had used a precipitation method. So for precipitation method, simple, you have to use the filter. So first you have to filter, Then in the filter, you will get copper carbonate, right? You have get your product. So what you can do the next step after this, you can do the washing and then you can do the drying. Why not crystallization method? Because it's already a crystals, right? Copper carbonate are just crystal. We just have to wash them and then we have to dry them so that the water can be removed. So option D is the right option here. Question 33. Copper sulfate is prepared by adding excess copper carbonate to sulfuric acid. Why is an excess copper carbonate added? Why added? Because we want all the sulfuric acid to be used in the reaction, okay? So that's why to ensure all the sulfuric acid has reacted. That is option B. Let's see question 34. Copper sulfate is prepared by adding excess copper oxide to warm dilute sulfuric acid. Which purification method are used to obtain pure solid copper sulfate from the reaction mixture? So copper sulfate is a soluble salt, right? All the sulfates are soluble except for 2-3 exceptions. So now we are using add excess copper method. It means one of our reactant is insoluble. So if one of our reactant is insoluble, so we have to first do the filtration so that we can remove it, right? So filtration will be the first step, right? Then for purification, what we will do? Filtration, and then we have to do the crystallization. Why crystallization? Because copper sulfate is a soluble salt. And to get a pure copper sulfate, we have to do the crystallization method in which we will evaporate all the remaining sulfuric acid. So that's why filtration and crystallization are the must step for this reaction. So 1 and 2 are the right option here. That is B. Question 35. Zinc sulfate is made by reacting an excess of zinc oxide with dilute sulfuric acid. The excess zinc oxide is then removed from the solution. Which process is used to obtain solid zinc sulfate from the solution? So we already have removed the zinc oxide, right? Now we are just left with our product and the reactant, that is sulfuric acid. This product is already soluble in it. So if your product is already soluble, then you have to use the crystallization method so that you can get a pure salt. So crystallization is the right answer here. That is A. Question 36. Aqueous ammonium sulfate is made by reacting aqueous ammonia with dilute sulfuric acid. How is solid ammonium sulfate obtained from the resulting solution? Okay. So you see aqueous ammonium sulfate is made. It means this salt is soluble, right? So our product is soluble. So now we have to get the pure one. How we can get the pure one? The only answer is the crystallization. We will evaporate it. Okay, so that all the dilute sulfuric acid is evaporated and we can just get the crystals of ammonium sulfate. So that's why option A is the right option here. Question 37. Copper chloride crystals are made by adding solid copper carbonate to dilute hydrochloric acid until no more dissolved. Okay, so which method we are using? Add excess method. How we know this one? Because they are using solid copper carbonate. Okay. So, and of course, the carbonates, salts are usually insoluble. So, which process is used to obtain pure copper chloride crystals from the mixtures? Okay, copper chloride are actually soluble one, right? All the chlorides mostly are soluble one except for 1 or 2 salts. So, how we can get now the pure one? Again, the crystallization method. When your salt is soluble, then you have to use the crystallization method. So, where we can find that crystallization method? Here, distillation of the mixture, wrong. Evaporation of the mixture, filtration, evaporation of the mixture, no, that's not right. Because if we evaporate the mixture, we will still be left with solid copper carbonate, okay, and also copper chloride. But we need the pure one, right? So for pure one, we have to first remove this solid copper carbonate. So we have to do first filtration. So that's why filtration options are right. Then filtration followed by drying of the residue. Not the drying of the residue. Why? Because residue is itself a copper carbonate. So we have to do filtration and then it will be followed by the evaporation of the filtrate. Because what is our filtrate? That is copper chloride dissolved in the dilute hydrochloric acid. So D option is the right option here. Question 38. Copper sulfate is formed by reacting excess solid copper carbonate with dilute sulfuric acid. Which process are part of the preparation of solid copper sulfate? So now again, we are using add excess method, right? So for add excess method, we have to do what? Filtration, and then we have to do crystallization because our product is soluble. So crystallization is important and filtration is important. So that's why option 1 and 3. So where we can find that is option A. So option A is correct. Question 39. Copper sulfate is made when copper carbonate react with dilute sulfuric acid. Okay, so this is the reaction. Pure copper sulfate crystals are obtained. Which reagent is in excess and how the crystals were obtained? So if you see, when copper carbonate, so copper carbonate is insoluble, right? So it means we have to use this one in excess. So copper carbonate is actually excess. So reagent which is excess is copper carbonate. Now, how the crystals are obtained? First of all, we have to filter this excess one, right? Copper carbonate is in excess amount, so we have to first filter it, and then we have to follow the crystallization method. So filter, evaporate the solution to crystallization point, and then cool. So that's why option B is the right option. Yeah. Let's see question 40. A student carries out an experiment to prepare pure magnesium sulfate crystals. The diagram shows the first stage of the preparation. Magnesium carbonate was added and then dilute sulfuric. So magnesium carbonate, of course, all carbonates are insoluble except for the 3 salts. Okay. He adds magnesium carbonate until no more reacts. So it means he is using add excess method because one of the reactant is insoluble. Which process should be used for the next stage? So for the next stage, he should use the filtration method. Okay, not crystallization, because the next step is to remove this excess, right? Excess magnesium carbonate. So the next step should be filtration. That is option C. Question 41. Silver nitrate reacts with sodium chloride to produce silver chloride and sodium nitrate. The equation for the reaction is shown over here. How is silver chloride separated from the reaction mixture? It's obvious. You can see here in the reaction, silver chloride is actually insoluble. So you can just do the filtration. We will just filter it and we will get our product. So filtration is the right answer here. That is D. Question 42. Which method is used to produce insoluble salts? So to prepare insoluble salts, it means both the reactants should be soluble, right? So then we have to use which method? Adding of excess insoluble base? No, wrong. Because if one is insoluble reactant, then we cannot get an insoluble product also because they will not react. So addition of excess metal to an acid? Wrong. Not all the metals can react with the acid. Okay, precipitation, yes, that is the right method because the precipitation method is used to produce insoluble salts in which we use 2 aqueous solutions. So C is the right option here. Let's see question 43. A pure sample of the insoluble salt barium carbonate can be made using the method given. Okay, all these are the steps. Which instruction is missing from step 5? So let's see one by one. Dissolve barium chloride in water. Separately dissolve sodium carbonate in water. Okay, mix the 2 solutions together, filter the mixture, and then dry the residue between 2 sheets of the filter paper. So insoluble salt, if it is made and we have filtered the mixture, so after that, what we will do? We have to evaporate the water. Okay, so we have to evaporate the water. And this one is already given here. Evaporate means we are drying it. But before drying, the residues, we have to clean it because that mixture can have some reactants, right? And if you dry it, maybe the reactant will remain in that residue. So that's why to get the pure sample of the barium carbonate, what we should do, we should first wash it with the water and then we have to dry it, okay? So wash the residue with water is the right option here. That is option D. Let's see question 44. Barium sulfate is an insoluble salt. It can be made by reacting copper sulfate solution with barium nitrate solution, okay? So what is the correct order of the steps to obtain a pure dry sample of barium sulfate from the reaction mixture? Okay, so barium sulfate is actually insoluble salt, right? So first method will be filtration method, right? Because we are getting a product. Now this product we already have taken. So what we should do, the next method, we should wash it with the water, okay? So we have to wash it with the water. So yes, filter and then wash the residue with the water. Now after washing, we have to left it to be so that all the water should be evaporated from it. So we can leave this residue in a warm place to dry. So that's why option D is the right option here. Let's see question 45. Which process is not used in the preparation of an insoluble salt? So if we are using an insoluble salt preparation method, filtration is important, right? Because it's insoluble, so we will use filtration. After filtration, we will also do washing, yes, right? And then we will also do the drying, not the crystallization. Crystallization is a method in which a soluble salt is actually produced. So you have to separate it from its reactant. So that's why we use crystallization method. So that's why this option is not right, because the salt is insoluble. So for insoluble salt, we use filtration, washing, and drying, not the crystallization. So option C is the right option here. Let's see question 46. Which method produces the salt copper carbonate? Okay, to produce a salt, of course, we need a neutralization reaction, right? Acid and base. Add copper oxide to water, then add excess aqueous sodium carbonate. This is a base. This is also a base, so we are not going to get copper carbonate here, right? So that's why this option is wrong. Now let's see another one. Add copper oxide to dilute sulfuric acid, right? Then add excess aqueous sodium carbonate, okay? And then filter off the precipitate. Yes, this option is right, because when copper oxide will react with sulfuric acid, we are going to get copper sulfate. And then this copper sulfate, when react with sodium carbonate, we are going to get copper carbonate. Okay, so that's why option B is the right option here. Why not C and D? Copper cannot react with dilute HCl, okay, right? So that's why this option is wrong. Add copper oxide to excess sodium carbonate. Again wrong, because they both are base in nature, okay? So they cannot react with each other. So that's why option B is the only right option here. So option B is correct. Question 47. Silver chloride is a white solid which is insoluble in water. Okay. What statement describe how a sample of pure silver chloride can be made? Okay. So if you want to make the silver chloride and it is insoluble in water, right? So it means we have to use both the reactants that are soluble. So we have to choose which method. Add aqueous silver nitrate to aqueous sodium chloride. Okay. And then filter it. Okay. So when silver nitrate, if you see, when it will react with sodium chloride, they both are aqueous in nature, right? So they can produce a insoluble salts. That's why option A is the right option here. Why we will not choose B, C, and D? We can see one by one. Aqueous silver nitrate to dilute hydrochloric acid. Yes, it can also produce, but then we cannot use the evaporation method, right? Why not evaporation method? Because first we have to filter, and then we have to, because it's insoluble. So crystallization is not a method for the insoluble salts. Again, this is also crystallization. We cannot use the method for insoluble salt. Again here, if you see here, add silver to dilute HCl. Silver will never react with the acid. So that's why this method is wrong. Okay, so option A is the only right option here. Question 48. Lead sulfate is an insoluble salt. Which method is suitable for obtaining solid lead sulfate? Again, if our product is insoluble, then both the reactants should be soluble ones. So we have to see if all of them are soluble or not. Aqueous lead nitrate, yes, they are soluble, and this one also soluble. Okay, now let's see one by one each method. So first we have mix it, right? Yeah, right. Then heat to evaporate. Wrong, because this is an insoluble salt, right? So first, after mixing, we have to do filter. So that's why after mixing these two, we have filter it, right? This one is also filter. Okay, so these two options are right. This one not right, because they have used the crystallization method. This is not used for the insoluble salt. So D or C can be right. Now let's see the next step. Filter, then collect the filtrate, then crystallize. Wrong. Crystallization is not used for insoluble salt. So now let's come towards the option C. Filter, then wash and dry the residue. So option C is the right option here. Question 49. Lead sulfate is an insoluble salt. Which process is not used to prepare a pure sample of this salt? Okay. Again, we cannot use the crystallization method. Why not? Because it is only used for the soluble salt or the soluble product. So we cannot use the crystallization method. Drying, filtration, precipitation are the right options. Okay. So A cannot be used. Question 50. Lead iodide is formed as a precipitate in the reaction shown. Okay. Which method is used to separate the lead iodide from the mixture? Okay. If you see, lead iodide is insoluble, right? So we cannot use crystallization. We cannot use distillation. We cannot use even evaporation. So filtration is the right method. After filtration, we have to do evaporation, but first of all, we have to separate. So for separation, because it is insoluble, so filtration is the best option, that is D. Let's see question 51. Aqueous solution of sodium sulfate and barium chloride are mixed. Which process is used to separate a sample of barium sulfate from the reaction mixture? Okay, see, barium sulfate is solid. It means it is a precipitate, insoluble salt. So for insoluble salt, of course, when you have to separate it, it is a simple method, that is filtration method. We can just filter it and then we can do the evaporation and drying, whatever, okay, washing and then evaporation. So filtration is the right option here, that is B. Question 52. Copper carbonate is formed when aqueous sodium carbonate is added to aqueous copper nitrate. Ionic equation for the reaction is shown over here. How is pure copper carbonate obtained from the reaction mixture? Okay, so our product is now insoluble, right? So first of all, we have to filter it. After we have filtered, we will wash it with the water. So there is no reactant. And after washing, we will dry it. So filter, wash, dry. So option D is the right option here. Question 53. Zinc sulfate is a soluble salt and can be prepared by reacting excess zinc carbonate with dilute sulfuric acid. Which piece of equipment would not be required in the preparation of zinc sulfate crystals? Okay, so now we are using the excess method because one of our reactant is insoluble. So beaker, yes, because we are preparing the reaction mixture, so we need the beaker. Condenser, no, we don't need any condenser over here. Evaporating dish, yes, we need because we have to do the crystallization method, right? And filter funnel, of course, we need it because we will separate the zinc carbonate. So a condenser is not the equipment that we need. So that's why option B is the right option here. Question 54. A salt is produced in each of the following reactions. Which statements about the product of the reactions are correct? Okay. So when magnesium react with dilute hydrochloric acid, we are going to get magnesium chloride, right? And hydrogen gas. So a flammable gas is produced in reaction B, right? Hydrogen is a flammable gas. Now, water is formed in all the reaction. Let's see. No, in this P, no, it will not form. So that's why we don't need to look for other options. But in the first one, we did not get water, right? So that's why this option is not right. All the salts formed are soluble in water. Now let's see one by one. Magnesium chloride, yes, soluble in water. Zinc sulfate, yes, soluble in water. Sodium chloride, yes, soluble in water. Copper sulfate, yes, soluble in water. So that's why all these are soluble in water. So we can choose 1 and 3. That is C option. So C option is correct. So all these questions were related to chapter 12. I will see you in the next video. Up till then, bye-bye.